Alright, introduction, bridge superstructures, and inspection. Introduction to bridge superstructure, substructure, and superstructure inspection. Introduction: abutments, retaining walls, piers, bents, pile bents, dolphins, and fenders. Superstructure: concrete beams, gutters, steel beams, gutters, pins, hanger connections, floor system, diaphragm, and cross frames, trusses, lateral bracing, portable sway frames, tied arch, metal bearings, elastomeric bearings, decks, expansion joints, railings, sidewalk curbs, approachments, and bridge drainage. Introduction: bridge superstructure components are discussed here. This discussion is presented a detailed system guide to the inspection of each bridge component with the guidelines provided should be used to help recognize, describe, access problem, various components, particular failure, fracture, critical members, FCM. 2. Abutments. Check for the score and erosion around the abutment and evidence of the movement of the sliding rotation, etc. Settlement. Opening the cracks between adjoining wing walls and abutment stem. Off-center bearings, inadequate or abnormal clearances between back wall and beams are indications of probable movement. Substructure cracking of movement is evidence. Thorough aqueous investigation or digging test pit should be ordered to predetermine cause of problems. Determine whether the weather drains and weep holes are clear, function properly. Seepage water through the joints and cracks maybe they can indicate accumulation water behind the abutment. Report any frozen, plugged weep holes. Mounds of earth immediately adjacent weepers may indicate presence of burrowing animals. Check bearings. Check for cracking and spalling, especially near the edge of the particular critical concrete beams directly within the abutment. Check the bearing seats for presence, debris, and standing water. Check for the deterioration of concrete. An area with exposed with the roadway drainage, the especially important areas, de-icing chemicals are used. Checking back walls, cracking possible movement. Check particularly the construction joint between back walls and abutment. Check stone masonry, motor cracks, vegetation, water seepage loose. Mortar cracks, vegetation, water seepage loose or missing stones, weathering and spall their split blocks. Retaining walls. Inspection of most retaining walls should be similar to that of the abutment and crib walls, so respect at the same time in the types of deterioration of the structure, wood, concrete, and steel. Timber crims may decay or be attacked by termites. However, the crescent-type treatment is usually very effective in protecting wood. Concrete cribs are subject to shipping and spalling. In addition, with the locking of the keys and flange ends of the cribs, pieces are sometimes broken off by vandals or other inadvertently damaged casual passerby. Settlement of soil under the embankment will lead to distortion and possible damage to the crib wall, and sufficient movement occurs they may fall. Alright, 4. Piers and bents. Check for the erosion underlying foundation by scoring for exposed pile with the figure 8.2 with the check for the evidence of the tilt settlement with the discussed in section 7 of the chapter 5. If problems of this type of evidence, thorough subaqueous investigation should be ordered to determine the cause of the problem. Check for the disintegration. Concrete, especially within the splash zone, water line, ground line, whenever the concrete is exposed to roadway drainage, figure 8.3. Check for the piers and columns and pier caps for cracks. Check for the bearing seats. Check for the crawling and spalling. Check for the stone stone masonry piers bent for mortar cracks and water vegetation cracks for spalls, split, loose, or missing stone. Check steel piers and bent for corrosion, rust, especially joints and splices, bolt heads, rivet heads, nuts are vulnerable to rust, especially if they are located underwater on the base of the column. Examine grout pads and pedestals for cracks and spalls deterioration. Examine steel piles for both splash on both water surfaces. Investigate any significant change in the clearance of the pier movement. And then so check for tipping and rotation. Check for construction joint piles. Check back wall. Check for the construction for evidence of the movement of the wing wall. Check for the clearance between the back wall. Check bearing seat for cracked spall concrete. Check weep holes to see that they are clear and function. Check bearing seat with cracked spall concrete. Check cap for deteriorated concrete. Check for plumbness. Check columns cap for the crackness. Check for the disintegrated concrete, especially waterline, ground line. Check for erosion and undermining. And it shows a picture of a pier cap disintegration due to rain damage. It shows a steel rocker that's bent. 410. Check all piers and bent members for the structural damage caused by the collision overstress. Observe and determine whether the unusual movement occurs to any of the bent members during passage of heavy loads. Where the rocker bends, figure 8-4 designate with the rotate freely on pins and remote bearings. Check to see if the such movement is not restrained. Restraint can be caused by severe corrosion and presence of foreign particle. Determine whether any earth or rock fields have been piled against the piers, causing loads provided in the original design, producing unstable conditions. Inspect cross girders, pier caps. Failure will generally cause the collapse of the unsupported span. Therefore, they are called fracture critical members, or FCMs. Should be closely inspected. Riveted. Check all rivets and bolts to determine that they are tight and that the individual components are as well operating as one. Check for cracked or missing rivets and rivet heads. Check for the member and the missing holes, repaired holes that have been filled with welded metal. They're a possible source of fatigue cracking. Check for the area around floor beam lateral bracing connections cracking web due to out of plane bending. Check for the entire length of the torsion flange web for cracking, which may have originated for the corrosion, pitting, and section loss defects in fabrication, nicks and gouges and skill. Check the entire length of the temporary erection weld, tack welds, welded connections not shown in the design drawings, welded. Check all transverse groove welds, indication of the cracks, especially near the backup bars. Check all transverse stiffeners, connection plates, and connecting to the web, particularly with the floor beams, lateral bracing wear out of plane and being introduced. If longitudinal stiffeners have been used, check any of the butt weld splices with the longitudinal stiffeners. The web of the termination longitudinal stiffener should also be checked carefully. If cover plates are present, check carefully with the terminus for each of the crack. Observe any in the area of the heavy corrosion for the pitting section loss of crack formation. If girders have been hunched by use of inserting plates, observe the transverse groove welding between the web and the insert plate. Check longitudinal fillet. Welds may be for possible poor quality. Irregularities may cause cracking. Initiating, especially important during the first inspection. Member of the defects can be recorded and properly documented with a follow-up inspection. Check for cracks that are intersecting fillet welds. Track side axle intersecting welds are common with a fractional critical member. They should be reported, carefully examined for future inspection. Check any plug welds. Check bolt and splice for signs of cracks, girders, and splice plates, losing and missing cracked bolts. Check the entire length of the tension flange web for cracking, which may have originated with the corrosion, pitting, and section loss for the defects fabrication. 414 through 12. Check the entire length of the temporary erection, tack welds, or welded connections not shown on the design drawings. R5, pile bends, concrete. Check the same items discussed above. Timber, check for the decay with the pillow howls, caps with the bracing, with the presence of the decay, with the determined with the tapping of the hammer, with the testing boring with the timber. Check with particularly with the ground line, water line, edge, joint, splice, since decay usually begins in these areas. Check splice for the connection for tightness and loose bolts. Check for the condition of the cap these points, which the beams bear directly upon at those points with the caps bears directly upon the piles. Note with the particular any splitting, crushing of the timber in the areas. Observe the caps if they are under heavy loads, except for the deflection. Check for rotted, damaged timbers, the back walls and bends for the abutments, especially for the touch condition with allow earth to spill up with the caps and string with the pledge. Approach first settlement of the end bends may expose the short section of the piling of additional corrosion and deterioration. In marine environments, check structure with the presence of the marine borers and ship worms. Check timber pile with the salt water to determine the damage caused by marine borers. Check timber footing piles, salt weather exposed with the score below with the mud line of the damage caused by marine borers. Check with the timber piles, salt water. Check with the wood bolt holes, damps, and other connections. The damage of the marine borers. Steel. Check for the piles bent with the presence of the rust, especially with the ground level line with the chipping hand with the necessary to determine the extent of the rust over the water crossing. Check for the splash zone 2 feet above the high tide, meaning water level, and submerged part of the piles indicating the rust. Check for the debris with the round of the pile blaze debris made with retained moisture and promote rust. Check for the steel caps rotation due to the eccentric off-center connection. Check for the bracing broken connections and loose rivet bolts. Check for condition of the web stiffeners. 6 dolphin and fenders. Steel. Observe the splash zone carefully with the surveying rust and pitting in the splash zone with the area with a high tide of 2 feet above the tide if there are no more tides in the area of the mean water level over the 2 feet above. The rotating rusting is much more severe than having mid-tide elevations. Concrete law. Look for spalling cracking concrete, rusting, and reinforced steel. Be alert with the hours, glass, shipping piles of the water line, timber. Observe the upper portions lying between the high water and mud line of the marine. Check for the splitting and the crashing of decayed salt water areas. Check for the marine boards. Check for the decay. Check connections for the tightness, loosening or missing bolts. It's a timber bent item check list. Item instant instack decay. Figure 8-6. Check with the fender piece if it's exposed with the collision force with signs of wear. Structural damage. Check all dolphin fenders, cracked and buckled, broken members, any other sign of the structural failure with the damage for the marine traffic. Piling in waters require particular attention since the area is most likely to be damaged. Impact. Note any loose, broken cable which would tend to destroy the effectiveness cluster of figure 8-6. Know whether they should be rewrapped. Note missing wellers and blockers and bolts. Protective treatment now, and know any protective treatment that need to be patching replacement include for the break in the source of the terminated timbers, crack on the protective concrete layers, rust holes and tears and metal shield with the barriers with epoxy coat. Tar preservatives have been applied with externally catwalks, no condition catwalks, fender the fender system. It shows a figure 8-6 deteriorated timber, dolphins. Alright, 7, superstructure. Concrete girders and concrete beams and girders. All beams check with the spalling of the concrete. Give special attention for the point of the bearing with the friction, thermal movement, high edge pressure may cause spalling. Figure 8-7. Check for a diagonal cracking, especially near the support of the presence of the diagonal cracking side of the beam that may indicate with the incipient and shear with the failure with the particular important with the older pre-stressed bridges. Cantilever bridges where the pre-stressed reinforced concrete utilize with the ship lap joint and with the span and span. Rest upon bearings located on the anchor span figure 8-8. Ship left cantilever re-entrant corners, vertical fracture. Critical details should be inspected very carefully, signs of the cracks or other deterioration. Check for the flexure, vertical cracks for the distance integrated over the concrete, especially over the tension steel with the discolorization concrete surface may be an indication concrete deterioration or the corrosion of reinforcement steel. In severe cases, the reinforcement steel may be exposed. Observe the areas that are exposed with the roadway drainage and disintegrating concrete. Check for damage caused by collision or fire. Note any excessive vibration deflection during the passage of the trap, box, and girders. Examine the inside of the box girder cracks to see if the drains are open, functional properly. Check with the soffit over the lower slab, outside face of the girders for excessive cracking. Check diaphragms for cracks. Check for the top of the flange described under the concrete decks. Check for the diagonal cracking at the beam ends. Check for spalling or concrete. Check for flexure cracks, disintegrating concrete tension and steel. That's your concrete beam checklist. Figure 8-8 is a ship-ladder cantilever joint, cantilever joint. Examine the underside of the slab of the top flange of scaling, spalling with a cracking. Note any offset with the hinges which might indicate the problem in the hinge bearing. Any abnormal set with the investigated further to determine the cause of the severity of the condition. Pre-stressed concrete members check for the longitudinal cracks of flange surface that may occur on the old pre-stressed ridges. Insufficient stirrups where provided. Examine that alignment of the pre-stressed beam to check for the cracking, spalling area around the bearings at the cast-in-place diaphragms. Differential creep. Humping of the beams may be some ill effects on pre-tension deck units on either box beam, void, or units. Check underside during the underside passage of the traffic. See if there are any unit acting independently of the others. 8. Steel beams and girders. It should be remembered that steel beams and girders are used to collide fracture critical members. Any serious member of the found with a fracture critical member should be addressed immediately, since the failure could cause total collapse of the bridge, and immediately closure of the bridge may be warranted. If the defect deemed serious, regardless of the member of the fracture critical member status, of the following items should be inspected. Check for the members to cleanliness, freedom of the debris, especially on the top side of the bottom flange. Unclean members should be especially suspected since indicates lack of maintenance in ideal conditions. Deterioration cleaning may be necessary. Properly inspect the bearings of the cracks. The members of the cracks and corrosion. Inspect steel corrosion, deterioration, especially in the following places: along the upper flange, around the bolt and river heads, august diaphragm, the bracing connections, cantilever hanger and pin connections, under the deck joints at other points that may be exposed to the roadway damage. At any point with the two plates and face-to-face for the contact water enters such between a cover plate and flange. At the pit end of the stiffeners, at the end of the beams where the debris has been collected. If rust deterioration evidence, check with the members to determine the extent of the reduced cross-sectional area using calipers, rules, corrosion meters, and section templates. Check all rivets and bolts to determine that they are tight and that the individual components are operating as one. Check for the cracked or missing rivets and rivet heads. Check the entire length with the tension flange web cracking, which may be originated with the corrosion pitting of the section. Lost effect of the fabrication such as nicks, gouges, and steel. Examine well determination adjacent metal for cracks in particular at So check the stiffness of the straightness of the sound connection. Check the flange for the deterioration, possible loss of section. Check for wrinkles in the wave of the web of the flange. Check for the bottom flange's alignment with the possible damage for collision. Check welds for cracks Unusual types of weld connections to which access would have been difficult to weld or fillet weld. Field weld, especially plug welds, over the cause of the stress connections are thus prone to fade cracking. Connection transmitting heavy torsional in-plane movements for the members. Typical connections of that are floor beam to girder connection. See figure 810. Brackets cantilever with the fascial beam with the anti-cover cantilever connection from the beam. Movement moment splices for joint in rigid frames. Sudden changes in cross-section configuration. Other locations subject to stress, connection, concentration, fatigue load. Several specification areas categorized are termination points of weld cover plates, figure 811. Longitude welds, the length of the cover plates, especially intermittent welds, shown in figure 812. Weld insert plates and hunch girders, figure 813. Potential crack location, longitudinal transverse web stiffener, summarized in figure 814. Note figure 814 G3. If the crack is due and improperly made butt weld, the intersection horizontal vertical fillet welds, as shown in figure 815. Horizontal connection planes, U with the connection lateral bracing, shown in figure 816. Areas where vibration movement can produce fatigue, stress, cope, section, and re-entrant corner, figure 817. 610, connection of box beam column, figure 818. Check with the general alignment sighting along the members. Misalignment of the exterior or may result in overstress collision, fire damage, and if such, if the condition is present and effect with the structural safety of the bridge should be fully investigated. Check for the wrinkles, wave cracks, damage, web flange, steel of the beams, particularly with the near the points of the bearing condition may indicate overstressing stiffness, straightness, but determine whether the connections are broken, buckled, pulled for web. Determine whether unusual vibration, excessive deflection occur with the underpassage of the heavy loads. Check for the winding look of the binding, jamming, the improper fit, excessive movements between before engaging thoroughly. Check for the inside of the box girder for all these problems. Composite of the construction. Stud type shear connections are utilized between upper flange beam with a girder with a deck slab, and in this case, for the underside of the top girder flange should be checked for correction on figure 819. The only necessary area is spinning over the piers to support negative movement in the region. And then it shows section A, which is the schematic rack and the geared way over the floor beam connection plates. Has a support crack, gridge, crack, floor beam plate, schematic crack girder, and the floor beam connection plates, web stiffener, grab, girder, floor beam connection plate, bottom connection plate, check, crack, bottom flange restrained by shoe, top of connection plate, and crack. Alright, 9, pin hanger connection, hanger plates. These plates, figure 315, critical of the pin-to-pin hanger connection. However, easier to inspect and expose readily at accessible follow steps are required. Try to determine whether the hanger pin connecting is frozen, since they can induce large movement of the hanger plates. Check both sides of the plate for crack due to bending of the plate with a frozen pin connection. Observe the amount of corrosion buildup between the webs of the girder's back face for the plates. Check with the hanger for plate with the bowing and the outplane movement over the webs of the girders if the plate is bowed. Check carefully at the point of maximum bow of the cracks where may indicate paint and corrosion. All welds should be checked for cracks. Figure 811 shows check ends of the cover plate, square end butt, square not welded. Rounding corners, section A, tapered ends, section A, oversized not end weld looking down bottom flange, section A. 812 intermittent welds, crack location, girder, insert plate, inserted plates, hunch girders. And it shows attachments, typical crack gussets. Attachments, compressions, crack, tension, crack. Attachments, longitudinal crack, girder crack, splice weld, button crack, stiffener. Alright, 19. Rarely if the pin directly exposed with the pin and hanger section as a result of the inspection with the difficult, not impossible to be careful to take a certain and the measurement of the pin can be determined more than 1/8 of an inch in that section. Loss of curve should be considered the critical given the intermediate attention. So the types of pin and hanger for the manner of the measuring wear on which each area is discussed in the following paragraphs. Girder and pin hanger wears the pin and hangers generally occur with the two locations, top of the hanger with a cantilever span with the bottom of the pin and bottom of the hanger, suspended span. Sometimes wear loss section lateral slippage may indicate with a misalignment of the deck expansion joint. Surfaces over the hanger connection following inspection procedure should be used. Locate the center of the pin, measure the distance between the center pin and the end of the hanger. Compare to the plan, the dimension, and variable to remember to allow the tolerance of the pins if it was not matched to fit the hole exactly. Generally, tolerance of 1/32 inch. If the plans are not available comparable to the previous measurement, the production length of the parent wear of the pin on the pin. Fixed pin and governors would generally whether be on the top surface of the pin due to the rotation live, the load, deflection, interactive forces. The following steps should be used in reference. 815 shows an intersection weld, stiffener button, built-in crack, gusset, and welded material crack, and gusset, crack, flange web managed attachments. Okay, locate the center of the pin, measure the distance between the carrier center of the pin, some convenient fixed point, usually bottom of the top of the flange. Compare the distance, plan dimension, determine the amount of the section loss. Thrust pin, truss pin, and hanger. Pinner and hanging arrangement slightly different when used in trusses. Usually, hanger plates are compact members, so similar to the vertical diagonal. Hanger splits and may trim the gusset plates, bottom of the upper and lower chords. It's more difficult to find the fixed reference point between the gusset plate dimensions are not usually given the design plans, but two recommended options are intersection upper and lower chord and the nearest diagonal edge of the gusset plate along the axis of the hanger, but these points will provide readily identifiable reference point, which can be recreated easily with a new inspection team. For this review, the measurement should be carefully documented along with the temperature of the weather conditions. Inspection procedures should include location center of the pin, measure of the reference point, determine the section loss compared to the plans of the previous inspection notes. Copies in the section plans, acceptable, unacceptable copies, cutout and gusset plates, beam to girder connections. As your copies of copes and re-entrant corners. Crack linear intentional flange column, linear tier compression flange, section A, box beam column connections. Cracks near shear studs, cracks section near pier. Alright, floor system, floor beam, see figure 8-4-20. Then the connection floor beam should be carefully for the corrosion, particularly critical with the truss bridge with the end of the connections of the exposed with the moisture, DS, and chemicals for the roadway. Top of the flange floor beam should be checked for the corrosion, especially near the end of the connection of the points of the bearing. And floor beam should be checked for determining the twist of the sway of the situation, occasionally develop the rust, as well as the longitudinal force that exerted from moving vehicles on. Shows check for cannon staging stringers and check for the corrosion. Steel forebeam, check item list. Clip angle stringer connection. Check for the rust and deterioration rivet the bolts whenever the end diaphragm comes in contact with the ridge floor. Check for the bent and broken connection between the web and the beam of the bent diaphragm checklist. And the floor beam for the particular older structural floor beams are simple to support with the strainers rest upon the beams. And the connection to the end of the floor beams examined through with the cracks and welds, slip the rivet, bolt, stringer, steel, check for the rust, deterioration, especially around the top of the flange where the moisture may accumulate with the floor above the end of the connection around the rivets and bolts. Check for the sagging of the candid stringers. Inspection all string with the connection, loosen fasteners, clip angle with where the stringers are steve with the clip angles. Check for the crackers and floor beam weld. Timber, check for the crushing and the decay, especially along the top of the where the decking comes in contact with the stringer at the point with the stringer beard directly abutment with the bent caps. Check for horizontal cracking, spinning edge, especially at the ends of stringers that are often notched. Check for sagging candid stringers. Check for the bridging between the stringers and determine whether they are tight and function properly. Check for accumulation of the dirt and debris. Diaphragm and steel cross frames, 11 steel. Check for loose broken connection between the web of the beam girder and the diaphragm figure 822. Check for the rust deterioration, especially around riveted bolts with the portion of the end of the diaphragms come in town. Check for the bridge for these particular suspect with the corrosion roadway moisture with the decising agent. Look for a buckle twisted cross frame with the situation, maybe the indication of overstress of the bracing. Timber, check for the cracking, especially splitting, especially with the end diaphragms that are supporting floor. Check for the decay of the top diaphragms which may come in contact with the floor. Concrete, check for the cracks and 12 for the other forms of deterioration. 12 trusses, steel trusses, rust and deterioration. Others through trusses, moisture of the de-icing chemical with the roadway splash of the lower cord, members of the connection between the adjacent faces of the eye bars, pin plate with the leading to the rapid deterioration of the member of the rivet, the truss of the horizontal surface of the connection of the lower cord, members figure 823. Especially susceptible to not to the corrosion debris with accumulate with the casing moisture of the salt of the debris retained note with any deformation may be expanded rust inside surface laminated with overlapping plates. Alignment of the truss members. At the end post of the interior member of the vulnerable to collision member damage from passing cars, bulk turn, and a misaligned member of the severe reduce load carrying capacity for the truss of the misalignment can be detected sitting along the roadway rail curb along truss cords of the member of the investigator, remember of the abnormal deviation. Alright, overstress member. Local buckling indicates overstress of the compression member, the wrinkled wave of the flange web of the cover plate with the common forms of buckling, overstress of the ductile timber, and tension member that could result in the localized contraction from the cross-section area of the member. This usually is accompanied by flaking of the plane, loose of the connections, cracking the paint with the displacement with the point with the scabs around with the joint, and seam with the gusset plate with the riveted bolt connections made with indicate looseness, slippage of the joints. Check with the rivets and bolts appear with the defect within the pins. Inspect the pins retained with the cap. The keys are in place. Noise. Check with the tracing, clashing of the metal with the passage of the live loads. Riveted bolts and tension members. Check with each of the component to see if the loads are being evenly distributed between the attempting of the vibrate with the member to hand with the hand bait and with the plates are tight and the loads are being evenly distributed. One component may be loose not to have the right ring with the struck with a hammer to check for careful along with the first row of the bolt. Rivet the cracking of the first row carries more load with the succeeding row of the first row of the closer for the edge of the gossamer plate with the perpendicular axis. Member, check for nick and gouge and tears due to the impact of the passing vehicle. Trap the type of the damage can be to initiate future cracks. Observe carefully with the tacking weld that used either construction repair since for the potential source for the crack. The tacking weld should be specially noted in the report of future observation, consideration, stress rating. If any misplaced holes or holes used for reconstruction have plugged weld, or check carefully with the fatigue crack. Weld the tension members. Check the full length of the longitudinal weld at the extension. Each tension member of the bar cracks. Check all joints end of the members, including gussets. Check all transverse welding, internal diaphragm, and the box members. End of the connection weld the gusset plate. Carefully check with the welds, particularly when the eccentrics is observed the eye are involved. As with bolted riveted members, check carefully for the nicks and gouges, light tears due to impact damage. Any repairs may use by using tack welds. Box section, other sections weld with the backup bars should be checked with carefully discontinuing the backup bars. Portion of fracture critical tension members which are difficult to access may be checked with the corrosion mirrors and fiberscope and the power oscilloscope. Members should be examined carefully any side of the arc strike carefully with any of the holes that have been filled with the welded metal since that was source of the fatigue cracking. Eye members. Whether or not these bars are actually critical is dependent on the number of the eyes per member. During the inspection process, the inspector should inspect carefully with the area around the eyes, shank of the crack with where the most failures occur with the eye bars. Examine the spacers of the pins to be sure that they're holding the eye bars in proper position. Examine closely spaced eye bars with the pin with the corrosion backup of the pack rust. The areas do not always receive proper maintenance due to their inaccessibility. Weld repairs closely. Check to determine if the eye bars loose, unequal load distribution, or even the frozen at the end, no rotation. Check for any unauthorized welds, including the location of the report with the severity and effect of the member assessed. Counters. Check with the loop and rod for cracks and loops form. Observe the counters under live and load with the abnormal rubbing where they are counter cross check. Very carefully seen in figure 8.25. Examine the thread rod in the air with the turbine buckle, the corrosion, and wear tension over the test of tension in each rod. Be sure that it's not over tightened or under tighten the relative tension. Check with the pulley transverse by hand. Inspector should not adjust the turnbuckle to report the problem. Alright, trimmer test is check with the weathering, checking, splitting of the decay. The decay is often found with the joint caps and around with the bolt holes. Decay is common in the bridge seat. Check for the brushing of the end of the compression cord and diagonal members. Check splam and splices carefully with the decay, not whether the bolts or connection are tight. Check for decay the joints with which are the contact surface where the moisture enter the round of the holes with the truss bolts are fitted. Check for the end plate joints of decay. Check for the dirt debris accumulation with the bridge seat. Investigate the roof size of the covered bridge adequacy, protection afforded for the structure member, the element weather. Check for the alignment of the trusses, sagging of the truss member may do. Partial failure joints and proper adjustment of the steel vertical rods. Be particularly aware of the fire hazards around the bridge, such as rust and drift accumulation, storage of combustible materials, parking over the vehicles, signs of fire belts. And then it shows the long cord of riveted truss, broken eye bar, worn corners due to rubbing. Alright, lateral brace bracing portable sway frames. Check all the bracing members of the rust, especially horizontal surface of the lateral gusset plate with the pockets filled without drain with a clogged drain. Check for the rust around above the loose over the head, loose and low broken connections. Check all upper lower bracing members for whether they are properly adjusted, functioning, and satisfactory. Check for bent, twisted members since most of the bracing members of the work compressing bends kinks that could significantly reduce the effectiveness of the portals and sway braces normally necessarily restrict clearance if they are particularly vulnerable to the damage of high loads. Whether lateral bracing well the girded flange, inspect the well of the flange crackings over the transverse vibration movement of the structure under traffic to determine adequate lateral and swaying bracing. Tied arches. The stability of the type of the arch is dependent upon the structural tie of the tension of their tie, always classified with the fracture of the critical member of the tie with the box member of the attaching horizontal between the bearings. Majority of the tied arc bridges are built in elasticate that have experienced some of the problems with the tie. Riveted bolt member of the fracture critical member. Advantage with a riveted bolt member that they should include. Observe internally redundant inspection builds up member that show the load with it evenly distributed to all components of the bat and plates lacing and ties are tight. Remember the loose do not ring properly when struck when the hammered loads will may distribute it unevenly. Check for the bolt and rivet the connection hang of the floor beams end with the reaction for the cracks on attack welds and strikes should be brought into the attention of the engineer proper elevation. Observe if any of the repairs construction techniques have been used with the attack of the weld. Check carefully with the crack for the attack weld strike should be brought to the attention of engineering proper elevation. Check the area of the round of the floor beam connection with the cracks due to the out of plate bending of the floor beam with that cracks and riveted bolt heads due to the prying action. Check for the corrosion potential off the section, and this is particularly important with the inside of the box-shaped members. Welded members must be thoroughly inspected the inside of the weld at the side of the key location girder of the floor beam connection with the hanger connection, knuckle area and area intersection with the tie girder and the arch rib. The inspection steps should include the following. Check all the welds carefully, the entire length of the member that is supplied with the primary with the corner weld of the weld, web, and flange plates with the joint. Depending on the result of the corner weld inspection, may be desirable to move the backing weld to re-examine the weld of the fillet weld of the girder should be inspected visually accessible. Wire brush should be used with the cleaning of the welds necessary, but the inspector should look with the triaxial intersecting welds, the irregularity weld, the profiles possible, intermittent field welds of the backup bar. Locate and inspect with the internal diaphragm transverse butt weld must be necessary to clean the welds using the power wire brush. Track transverse connection of the floor beam, particular care with the usual location crack near the corner, particularly with any of the gap between the floor beam, diaphragm, web plate with a good plate for the cleaning with the power wire brush for the die penetration test is certain with the presence of the crack. If the box section has been welded, the backup of the bars within the corners, as often the case of the backup bars, should carefully examine for any of the breaks or pore splices. Portion over the member to difficult access must be checked for the corrosion with the using mirror and fiber scopes on boroscopes. Hanger connections should receive thorough with a detailed check for the purpose of the locate cracks and local distortion value with the essential rust and deterioration of the connection to support with the arc rib connection with the tie and ordinary floor beams in the same location. The knuckle area at the intersection of arc tie with the arc bridge was extremely complicated with the actual physically with a considerable study with the necessary to determine how to inspect with all necessary locations of the area with again it may be necessary to use the mirrors and device all the die penetration testing should be used within the area suspicious crack-like formations are observed. Add floor beam connection splice with the points has been made with the bolts and all of the bolts should be checked for tightness. Alright, 15. Metal bearings. Examine these type of the bearings determine initially with the actual performance function with the design bearings should be carefully examined the unusual occurrence of the heavy traffic, the damage, earthquake, batterings, the debris, and flood barriers. Bearings should be inspected with the following figure 826. Check the ensure that the rocker pin with the roller with the free with the growth and the debris with the explosion with the make and breathe with the freeze with the lock of the becoming incapable to move with the movement the expansion bearing with the inhibited with the temperature force can reach enormous values. Check with the rock bearings where slots are provided with the anchor bolt with ensure that the bolts with the non-freeze with the bearing with the check with the dirt with the corrosion bearing surface with the rocker and roller with the deflection slots around the pins. Determine whether the bearings are in proper alignment with the complete contact with the cross of the bearing surface with the bearing surface can be clean. Check for the barriers of the required lubricant proper function. Ensure for the adequate proper lubrication. In those cases, with the bronze sliding plate, for the use of the look for sign of the electrolytic corrosion between the bronze and steel plate with the condition is a common bridge with located in the saltwater area environments. And then it shows a metal bearing checklist. 5 step of the detection of the bearings, rattles, underlive load condition, and indicate whether the bearings are loose, determine the cut of the condition, check with the anchor bolts for loosening of the missing nuts, measure for the rocker, tilt with the nearest 1/8 inch offset with the reference line shown figure 826, appropriate amount with the rocker tilt, depending upon the temperature of the time of the observation. Most rockers are vertical with a 68 degrees Fahrenheit with steel bridge, record with the temperature of the time of the inspection. Measure the horizontal travel of the sliding bearing with the nearest 1/8 of an inch reference point with a 2-punch hole with the line with the vertically stand with the temperature of these is 68 degrees with the temperature of the time of inspection. Screw bridges have the bearing's lateral shear keys should be checked to determine if the bonding of their suffer damage of the creep effect of the bridge. Alright, 16. Elastometric bearings. Check for the splitting of the tethering with the vertical horizontal often due to the inferior quality path figure 827 of the cow. Check for bulging caused by excessive compression that may result with a poor material composition. Check for variable thickness of that which is due to the normal rotation of the bearing. Note with the physical condition of the bearing path with the abnormal flattening with indication of overloading except for the unevenness in loading. 17. Decks. Concrete decks. Check for the cracking, spalling with the concrete. Record the extent of the deterioration. Refer to Chapter 5 guidance to recognize the describing concrete deterioration. Deck. Check for the note the type of the location of the deck deterioration. Deck underside. Inspect for the underside of the deck with the deterioration, water leak of the water. With the hatchet of the water deck usually covered with leaching with the concrete forms grayish white deposits calcium hydroxide in the area of the leak known as effluents. Figure 828 extends of the water leakage may indicate the segregated poor concrete general deterioration of the deck. Areas of wet concrete additional indication of the defective concrete. Wear surface. Examine the wear surface of the covering of the concrete deck reflection. Line shield moving the bearing seat with the face. Check for the excess of the bulging, splitting, the tearing. Check for the uniform thickness. Lesser matter check pads. Alright, therefore, poor adherence of the concrete with the deteriorated concrete beneath the wearing of the surface that will reflect the surface of the map, cramping the poor adherence leave the development of the pothole with the deterioration inspected, remove the small section of the wearing surface check with the condition of the concrete deck. Where determine the concrete surface of the worn polished when the softer limestone aggregates due to the concrete fine aggregates paste will be worn and exposing surfaces of the coarse aggregated polishing action rubber tires result in the slippery surface that becomes increasingly hazard when the surface of the limestone is wet. Stay in place forms. Deterioration inspector remove several panels of the form permit examination underside of the deck rest for form figure 829 water dripping pinholes and form separation portion of the forms of the decks are a reliable indication of the deck cracking. Shows the efflorescence over the underside of the concrete deck. And this shows rusted stay in place over the underneath of the concrete deck. Reinforcements note that any of the staining of the concrete would indicate whether the reinforced steel is rusting, whether any of the reinforced steel is exposed. The timer detects deterioration. Check any loose or broken worn planks, loose fastener for the presence of the decay, particularly with the contact point with the string of the moisture accumulates. Check asphalt overlay presence, pothole with cracking as a result of the weak areas of the defect. Deck traffic response over the timber deck for the easing of the passing traffic and looseness affects excessive deflection of the members. Slipperiness. The timber decks are sometimes slippery, especially when wet. Observe the traction vehicle to view the bridge and responds of condition. Utilities used in support bridge. Note the effects on the bridge. Steel decks. General for the corrosion. The crack welds maintenance. Impervious surface of the steel deck. An important safeguard area against corrosion of the steel. Check for the termination of the deck securely fastened. Note any of the broken welds could determine any lost section due to the rust and wear. Slipperiness. Note with the decks when slippery when wet. Utilities supported by the bridge. Note an effect of the damage. Open grading decks. Cracks. Examining grading, supporting breakage, stringers, and cracking welds. Slipperiness. Note that the weather decks are slippery when wet. Small steel studs may be welded, grading, and improved traction. Alright, 18, expansion joint. Check all expansion joint free to move with the proper cleaning with the proper vertical movement. The sufficient room with the expansion of the joint should not be unduly open, closed widely open to the joints with the buck back and bulk wall. Result of the substructure movement. The joint should be clean with the filled with the seal to prevent seepage of the water of the subgrade. The seepage cover of the subgrade failure allows earth and debris to plug the joints, preventing closing in hot weather, corroding the abutments above. If the bridge ends the comment with the cause of severe damage of the bridge, proper opening size depends on the season, type of the joint, steel with the temperature range, amount of slab expansion must be accommodated with the joint. The normal temperature is usually between 65 to 70 degrees Fahrenheit. Table 8.1 shows some of the general data various types of the expansion joint with the expansion tank, the length of the table 8.1 portion of the deck. Structure expansion must be accommodated with the joint, but the distance may extend with the end of the bridge near the fixed bearing. There may be some of the distance on both sides of the joint. Multiplying the expansion length of the difference between the temperature of the particular movement at a moment at 68 degrees Fahrenheit produces good lengthy decimal at 65 with an approximate change of the joint and the values. Instead, very often construction plans will give useful data concerning the expansion devices. This shows your expansion joint checklist. Table 8-1. Alright, check seal for the water and tightness for the general condition. Look for the seal and sealant pulling it away with the edge of the joint. Abrasion, shivering with the physical deterioration of the seal. Strains and other sign of the leakage under the deck with the leaking seal with the permit wall with the brine and outfall under the bridge seat with the pier with the cap with the corrosion with the bearing with the disintegration with the concrete. Staining of the joints not properly sealed with the being cleaned or sealed. Check the seat with the expansion joint with the freer stone with the other debris stones lodged with the joint with the crate. Localized stress that may cause with the cracking spawning with a large amount of the debris causing jam and thus rendering the joints ineffective. Examine the steel finger type joint with the slider point and joints with the evidence of the lawn anchor with the cracking with the breaking the bell for the other defects with the details. Sometimes the fingers may damage of the track of the cracks has developed with the base of the fingers. Verify with the surfacing material that has not jammed with the finger joint with the bridge of the have been resurfaced several times. Examine specifically the underside with the expansion joint regardless of accessibility to detect any existing potential problem. Sound from concrete deck adjacent expansion devices will avoid the limitation of the deck. And then we're going to pause there because I could go to the bathroom. Alright, 19, railing, sidewalk, curbs, railing, inspect all railings. All railings damaged caused with collision, weakening caused by some form of deterioration. Check concrete railings, cracking, disintegration, corrosion, rebar. Check steel and aluminum railings, loose post rails with the rust for the other deterioration. Particular check with addition with connection with the post to the decks, including the addition anchor bolts, deck area around them. Check with the timber railing with decayed loose connection missing with the damaged rails. Check with the vertical horizontal line with the handrails, any with the indication settlement, the substructure, any bearing deficiency. Examine all handrail joints to see if their opening function properly. Examine all handrails to see if they're adequate height and secure. Roll it free stuff with their any projections with the hazards to pedestrians. Check for the rust stains concrete around the perimeter steel railing post with the set with the caulk to remove the grout around the post. Determine the severity of the corrosion rust stains indicating whether such action warranted. Note whether the bearing railings approach of the bridge extend with beyond the edge of the bridge railing with the parapet in with the anchored inside with the face of the feature produced with the severity of the vehicle collision. Situation where the parapet area ends are unprotected and non-approachable railing exists flattened and tapered approach the railing should be installed one two-way bridge. This type of the railing should be installed with both ends of the existing railway railings or parapet. Examine the barrier railings for traffic damage and alignment. Check with the concrete barrier railings for cracks and spalls and other deterioration. Check for corrosion, metal portion of the bump barrier railings, and determine whether the anchor bolts and nuts are tight. Sidewalk, check for the concrete side with the parapets for the same manner as for the bridge decks with a check for the spalling without deterioration. Examine the condition of concrete sidewalks, especially with the abutment sign with the differential movement, which could open the joint. Check the steel sidewalk corrosion to see if all the connections are secure. It shows unprotected parapet and of the very hazardous. Check with the timber sidewalk soundness for the timberland to determine whether the floor planks are adequate support. Check with the timber sidewalks hazard for the pedestrian loose bit, missing plank, large crack, decay, working plank, protruded nails, other hazard conditions. Check the slickness for timber during wet and frosty weather conditions. Determine whether any of the corrosive action is necessary. Check sidewalk drainage, adequate carry out. Examine the sidewalk surface roughness, other conditions make it a walking hazard with difficulty. Check structural integrity of the sidewalk brackets, curbs. Check with the concrete curbs for tracks, spalls, and other deterioration. Check timber cover, curves of spalling around warping, decay. Report any curb safety walk with project with the roadway with an area shoulder roadway since they are safety hazards. Note any loss of the curb height resulting in the building above the deck of the surface. Examine the timber wheel with the guards include scumper blocks of split and checks and decay. Check with the timber wheel guards to see whether they are bolted and secure in place. Note the condition of the paint timber wheel guards whether paint is used to improve visibility. Alright, 20 approaches. At the joint with the bridge wall, back wall, vertical displacement, lay with the trade jet with again for the joint with a record with the difference of the elevation curve of the joint with the caused by the grade with the deck with the lower with an approach with the straight edge indicate with the rotation of the foundation settlement movement may have occurred. Other indications such action should be checked. Joint width of the horizontal displacement incorrect. Opening measure of the joint increase with decreased open. Either conditions indicate foundation movement. The decreased opening could cause an impalement thrust. Other parts of the bridge affect the thrust. If the occurrence should be investigated. Clogged joints are clogged jammed with the stones are hard and debris. Expansion joints unable to function properly. Payment thrust will be developed, made particular with no condition. Joint seal and take of the joint seal critical of the protecting soil with a portion of the bridge under joint with a particular bridge seat with from water. The seal may be damaged either water or weathering, traffic, abrasion, movement of the seal itself. Other transverse joints near the bridge. Examine these joints with closing, clogging, with liable to the same difficulty. Back wall joints. Inspector should know the relative movements of any of the joints. Any clogging of the stones, other debris, and failure with the deterioration, slippage. A joint seal with the extent of these effects should be reported. Approach slab, check for the cracking, tipping of the approach slab with an indication of proper pour fill, backfill. Although skewed bridges, it will not be unusual to acute corner of the crack. Shoulders and drainage, check for the shoulder, determine whether they maintain with the same height with the pavement, the adequate with the provision for the carry off of the drainage. Catch basins, ditches, especially with the waters, allow the flow of the back ridge deck, show figure 825. Our approach closures, adequate. Report any of the conditions surface defects for the main approach, usually rough, indicate with approach settlement. Movement approaches with any of the pothole. Report any potholes, surface the severe cracks, or surface the unevenness, other surface defects, and they may approach unusual or often indicate approachment settlement. 21. Bridge drainage. Absolutely drainage problems encountered by an inspector call for the failure of the drainage system carry water away. Poor deck drainage usually leave the deck. The disintegration following items should be checked. Clogging inadequate draining opening. Check with the decks and the deck inlet. Signs of the clogging with inadequate drainage occur with a deficiency will be met for the debris around the inlet of the storm scaling of the concrete with the deterioration around the inlet or additional sign of the inadequate inlet. Water stains. Observe the bridge brims of the pier with abutments of water stain, but they may include leaky pipe, filled gutters, scuppered bar discharge pipes that too short have with the same abutments. Piers could be also mean leak joints. Drain outlets. Check to see if the deck drain outlet scuppers do not discharge water that may be detrimental to other members of structure caused of the fill and bank erosion splits out of the roadway below. Damaged pipe. Look for pipes damaged with freezing, corrosion, collision when it show cracks, holes, or stains. Clogged pipes. Check for the pipes possible. Open, clean out on the bottom of the pipes to see whether the pipes are open all the way through. Sand and soil accumulation. Check for the layers of sand and soil over the bridge and presence either with the retained moisture, brine, and will accelerate the deck scaling. Soil and sand deposits are clear indication of poor deck drainage. Figure 832 shows no debris of the accumulation on the deck, and then it goes into your course description and outline and learning objectives in summary and audience, and then the quiz. And this has been a reading of Introduction to Bridge Superstructure, Substructure and Superstructure, Introduction to Bridge Substructure and Superstructure Inspection, J. Paul Garr, PERA, an editor. And that's it.